Hi guys, I hope you are fine. Today is 21st January, but this is the problem of the day for 20th January. I don't know what happened to my laptop yesterday, but it was unable to save any video. So today I am going to explain this to you. As I have so the question is the problem of the day for 20th January. The question is first complete painted row or column. Okay, I will explain it. I will explain it quickly. The topics are array, hash table, and matrix. Right. So the question is you are so let me explain it directly to you. So we are given a matrix. The dimensions are m cross n, right? And we are also given an array with the dimensions with the length of m cross n, right? Both the matrix and array will contain all the numbers from 1 to m cross n, right? So both the matrix and array, okay, will contain all the numbers from 1 to m cross n, right? Okay, now what we have to do is we have to iterate through the array. Okay, so let's say first number is 1, so we will paint 1, right? The second number is 3, so we will paint 3. Okay, so this is how we have to iterate through the array and paint the number in the matrix. Once we got our row or a column which is fully painted, so we will return that iteration, right? So in this first example, at 0 we will iterate 1, at 0 we will paint 1, at 3 at iteration 1 we will paint 3, at iteration 2 we will paint 4, and we got a row, we got a row and a column which is fully painted, so we will return 2. Simply here at 0 this is the case, at iteration 1, 2 and 3. So at iteration 3 we got a fully painted column, so we will return 3. Fine. Now we will discuss the native approach. Let's say the other dimensions are n square, n cross m, right? Assuming n equals to m, right? So what we have to do is, in the native approach, this is the most basic approach, and the most basic thing which we can do in this particular question. So what we can do is we can iterate through the array, right? This we can done in n square, and in each iteration, let's say we got ARRI, right? So we will then iterate through the matrix and find the ARRI, right? So that will also be done in n square, right? We will make up a painted matrix which has the dimension of n square, which is m cross n, containing the details of the painted row and columns, right? Good. Painted cells, we can say. Now so if we have painted 3, so we will check this row and this column, okay, to check if it is fully painted or not. So this will be done in 2n, right? 2n means n, because we are ignoring the constant, so the overall time complexity is n square into, because these are the iterative, or I can say these are the successive loops, right? So in each iteration we have to do this, and in each operation we have to do this, right? So the time complexity is n to the power 5, right? Okay, good. So what can we do to decrease the time complexity or optimize this approach? Can we do this in lesser time complexity, and this in lesser time complexity? So for optimizing this approach, what we can do is we can create a coordinates array, right? And we will iterate through the matrix and store the coordinates in that array, right? We can do this in time complexity of n square, okay, but we will do that separately. That will not get multiplied, that will got added, right? So because we don't have to do it in each iteration, of n square, right? We have to do that separately one time only, right? So that will be that the time complexity will be added. That will also take space of n square, but that okay, we already have a space of n square in the native approach. So so by doing this, we can reduce this step, reduce the time complexity to O1 again, right? Again, for reducing this, what we can do, we can create the counters, right? And if we paint any cell, so we will increase the counter of that row and that column. And if the counter reaches the dimension of the matrix, so we will return. So this so this is the approach. So first we have to make a map of a matrix which is which is the coordinate array, and we can iterate through the map, right? And store the coordinates of matrix, right? So that is a time complexity of mn, but separately. So then again we can create the counters. So the space complexity will be m plus n, which is again less than m and n. So that is okay. Now what we can do, we can iterate through the array and do this operation. The iterate through the array and find the coordinate and where. So that will be done in m and n, m cross n, right? And we can increase the counters in O1. So overall time complexity will be m cross n, and overall space complexity will be m cross n, right? So as we can see, guys, we are reduced to n to the power 5 to n square, which is a very good thing. So let's discuss, let's go through the code once. We have m, we have n, we have the coordinate array, which is a map of matrix, right? We will store all the coordinates in the coordinate array. So okay, we have the counters here. So now we are iterating through the array. We are finding the x and y coordinates of the I. So the array and the matrix is starting from 1, and our coordinate array is starting from 0. So we are using -1 here and -1 here also for making it as 0 indexed, right? We are increasing the counter in O1, and we are checking if we have reached the dimensions, right? This is also done in O1. So these 4 operations is done in O1. So this loop is of n square, and this loop is of n square. So overall time complexity will be n square. For creating this, space complexity will be m and n, and for creating this, space complexity will be m and n, right? So we will return the iteration here, right? We have the solution, and we solved this in the 87.88% beat, which is very of course very acceptable thing. So I hope you find the solution well. Sorry for the inconvenience, because I don't know what happened yesterday, but it's okay. I mean, I'm explaining, I have explained everything in detail again. I hope you find something valuable in this video. You gain some knowledge about how to optimize the native, how to think a solution, how to think about native approach and then optimize it to the optimized approach. So I am going to solve every problem of the day regularly and upload the video on YouTube. If you have if you are practicing DSA daily, you can go through these videos and practice the problem by your own. I will share this solution in the comment section. You can ask your friends to go through these videos also, so that they also get some knowledge and practice the DSA daily. Thank you, guys. Thank you for your time. Thank you for your patience. I hope if you have any doubt, you can ask me in the comment section any day. Thank you.